The average American household uses about 300 gallons of water per day. On a homestead, that number can double. Livestock, gardens, cleaning, cooking, drinking. And here's the problem. Most people buy land, build a house, and then figure out water. That's backwards. Water is the single most important system on any homestead, and choosing the wrong one can cost you thousands or leave you completely dry in the worst possible moment. Today, we're breaking down every homestead water system, from the simplest setup that costs almost nothing to the most advanced systems that can run an entire off-grid property. If you're planning a homestead, watch this before you build anything. Level 1. Rainwater harvesting, the simplest entry point. This is where most homesteaders start, and for good reason. The concept is dead simple. Rain hits your roof, gutters collect it, pipes directed into a storage container, you use it. A standard 1,000 square foot roof collects roughly 600 gallons of water from just 1 inch of rainfall. That's 600 gallons from a single rainstorm. For free. Scale that up to a larger barn or house roof, and the numbers get serious fast. At the most basic level, you're looking at a rain barrel connected to a downspout. Cost: under $100. You can build one from a food-grade 55-gallon drum in an afternoon. This works for garden irrigation, livestock watering, and general outdoor use. For household use, you need to step it up. A proper rainwater catchment system includes a first flush diverter. This dumps the first few gallons of dirty roof water before clean water enters your tank. Then a storage tank, anywhere from 500 to 5,000 gallons depending on your needs. And filtration. At minimum, a sediment filter, ideally followed by a carbon filter, and UV sterilization if you want potable drinking water. Total cost for a serious rainwater system with filtration: $1,000 to $3,000. That's less than most people spend on a used car. The limitation: it has to rain. In dry climates or during drought, rainwater alone won't cut it. Some states also restrict rainwater collection, so check your local laws. But as a supplemental source or a primary system in wet climates, every homestead should have at least some rainwater collection. That's water falling from the sky. The next system pulls it straight from the ground. Level 2. Hand-dug wells, the old-school approach. Before drilling rigs existed, every well on Earth was dug by hand, and in areas where the water table is shallow, within 10 to 30 feet of the surface, hand-dug wells are still a legitimate option. The process is exactly what it sounds like. You dig a hole, line it with concrete rings, stone, or modern liners to prevent collapse, and cap it to keep out contamination. Water seeps in through the bottom and sides from the surrounding water table. Getting water out is manual. A bucket and rope is the most primitive method. A hand pump, the classic pitcher pump you've seen on old farms, is the standard upgrade. These are reliable, require no electricity, and can last decades with minimal maintenance. Cost is mostly labor. If you dig it yourself, materials run a few $100s for lining and a pump. Hiring someone pushes it to $1,000 to $3,000, depending on depth and soil conditions. The output is limited. Hand-dug wells produce less water than drilled wells and are more vulnerable to surface contamination. They can also go dry during drought, but they're one of the only water systems that requires zero electricity, zero technology, and can be built with basic tools. For a backup water source or a small homestead with a high water table, a hand-dug well is surprisingly practical. But most modern homesteads need something deeper and more reliable. Level 3. Drilled wells, the gold standard. If you ask 10 experienced homesteaders what the most reliable water source is, 9 of them will say a drilled well. A professional drilling rig bores down anywhere from 50 to 300 feet, sometimes deeper, to reach a reliable aquifer. A submersible pump sits at the bottom, pushing water up to a pressure tank in your house. From there, it functions exactly like city water. Turn the tap, water comes out. Drilled wells produce consistent year-round water that's naturally filtered through hundreds of feet of rock and soil. The quality is generally excellent. Many well owners never need any additional filtration beyond basic sediment removal, though testing is always recommended. Cost is the big barrier. Drilling runs $15 to $50 per foot, depending on region and geology. A 200-foot well at $30 per foot is $6,000 just for drilling. Add the pump, pressure tank, and piping. Total comes to $8,000 to $15,000. In difficult geology, costs can exceed $20,000. And there's no guarantee. A driller can go 300 feet and hit nothing. You pay for the hole whether it produces water or not. The pump runs on electricity, so if the grid goes down, your water goes with it. Smart homesteaders solve this with a solar-powered pump, a generator backup, or a hand pump installed on the same well. Despite the upfront cost, a drilled well provides the most consistent, highest volume water of any system on this list. If your land has accessible groundwater, a drilled well should be your primary source. But not everyone has groundwater, and not everyone has the budget to drill. The next system costs nothing to operate and has been working for thousands of years. Level 4. Natural springs, the homesteader's jackpot. If your property has a natural spring, you've hit the water lottery. A spring is groundwater that flows to the surface on its own. No drilling, no pumping, no electricity. Water just appears. And it keeps appearing because it's fed by an underground aquifer under natural pressure. Spring water is often some of the cleanest, best-tasting water available. It's been naturally filtered through rock and soil on its way to the surface. Many springs produce water clean enough to drink without treatment, though testing is always the smart move. To use a spring properly, you need to develop it. That means building a spring box, a watertight collection basin at the point where water emerges. The box captures water before it contacts surface contaminants and pipes it wherever you need it. If the spring sits uphill from your homestead, you get gravity-fed water pressure with zero mechanical parts. No pump, no electricity. Just physics doing all the work, 24 hours a day. Spring output varies wildly. A small seep might produce 1 to 2 gallons per minute. A strong spring can push 10 or more gallons per minute. That's over 14,000 gallons per day, more than most households could ever use. The downside, springs are location dependent. You either have one or you don't. They can vary seasonally, and developing one properly takes initial labor and plumbing knowledge, but cost is minimal once built. A few $100s for the spring box, piping, and a storage tank. Ongoing cost is essentially zero. For any homesteader lucky enough to have a spring, especially one positioned uphill, this is the best water source that exists. Level 5. Surface water. Creeks, streams, and ponds. Creeks, streams, rivers, and ponds are all potential water sources. They're visible, accessible, and often abundant. But they come with a critical warning. Surface water is the most contaminated category on this list. Unlike groundwater, surface water is exposed to animal waste, agricultural runoff, sediment, bacteria, and parasites. You cannot drink it straight. Every drop needs filtration and disinfection before it's safe for humans. For non-potable use, livestock watering, garden irrigation, fire suppression, surface water is excellent. A submersible pump in a creek moves hundreds of gallons per hour. For drinking water, you need serious treatment, sediment filtration, carbon filtration, and either UV sterilization or reverse osmosis. The biggest risk is reliability. Creeks dry up in summer, ponds stagnate, and water rights laws in many states restrict how much you can legally divert. Best used as a secondary or non-potable source alongside a well, spring, or rainwater system. Every system so far has one thing in common. Water exists somewhere, and you need to get it where you need it. The next 3 systems are about how you move that water. Level 6. Gravity-fed systems. Zero electricity, zero maintenance. A gravity-fed system is not a water source. It's a delivery method, and it's the most reliable delivery method that exists because the only thing powering it is physics. The concept is simple. Place your water storage tank higher than your house. Water flows downhill through pipes. You get running water at your tap. No pump, no electricity, no moving parts. The math is straightforward. Every 2.3 feet of elevation difference between your tank and your tap creates 1 psi of water pressure. Standard household fixtures need about 20 to 40 psi to function properly. That means your tank needs to be roughly 46 to 92 feet higher than your house for full household pressure. Don't have a hill? Build a platform or tower. A 12-foot elevated platform with a 55-gallon drum gives you enough pressure for a basic sink and outdoor hose. A larger tank on higher ground can supply an entire household. The tank gets filled by whatever source you have: spring, well, rainwater, or a pump that fills it periodically. This system pairs perfectly with solar pumping. A solar-powered pump fills the elevated tank during daylight hours. Gravity feeds the house 24/7, day and night, cloudy or clear, power outage or not. Gravity-fed systems are silent, maintenance-free, and work indefinitely. If gravity stops working, you have bigger problems than water pressure. Cost depends on the tank size and elevation setup. A basic system with a used IBC tote on a platform runs a few $100s. A buried cistern with engineered piping on a natural hillside runs $2,000 to $5,000. Level 7. Solar-powered pump systems. Off-grid muscle. For homesteads without the elevation advantage for gravity, solar-powered pumps are the next best thing. A solar pump system works like this. Solar panels generate electricity. That electricity powers a pump. The pump moves water from your source, well, cistern, creek, pond, to where you need it. Storage tanks or pressure tanks keep water available when the sun isn't shining. There are 2 main types. DC solar pumps connect directly to panels and run only when the sun is out. These are simpler and cheaper and work well for filling storage tanks during the day. AC solar pumps use an inverter and battery bank, allowing them to run anytime. More expensive, but more flexible. For deep wells, solar submersible pumps can push water from 200 or more feet underground. For surface water or shallow wells, smaller solar-powered transfer pumps handle the job at a fraction of the cost. A basic solar pump setup for a shallow well or cistern runs $500 to $1,500. A deep well solar system with battery backup can run $3,000 to $8,000, still less than running a conventional well pump on grid electricity for years. The ideal setup: solar pump fills an elevated tank during the day, gravity feeds the house at night. Zero ongoing energy cost, zero grid dependence. Level 8. Ram pumps. The genius zero energy pump. A hydraulic ram pump is one of the cleverest devices in homesteading. It uses the kinetic energy of flowing water to pump a portion of that water uphill, with no external power whatsoever. Water flows downhill from a creek or spring through a drive pipe into the ram pump. The pump uses that momentum to slam a valve shut, creating a pressure spike that forces a small amount of water up through a delivery pipe to a higher elevation. Efficiency is about 10 to 20%. If 10 gallons per minute flow in, 1 to 2 gallons get pushed uphill. Sounds low, but the pump runs 24/7 with zero fuel and near zero maintenance. Even 1 gallon per minute adds up to 1,440 gallons per day. Ram pumps can push water 10 to 20 times higher than the fall of the drive pipe. A 5-foot drop from your creek can push water 50 to 100 feet uphill. Cost: a DIY ram pump can be built from standard plumbing fittings for under $100. Commercial units run $200 to $1,000. The catch: you need flowing water with consistent elevation drop. No flow, no pump. For homesteads with a creek or spring and any amount of slope, a ram pump is one of the smartest water investments that exists. Level 9. Cisterns. The big storage solution. Every water system needs storage, and cisterns are the heavy hitters. A cistern is a large, sealed tank designed to hold thousands of gallons of water. They can be above ground or buried underground. Underground cisterns are the most common for homesteads. Buried below the frost line, they're protected from freezing and temperature fluctuations. Common materials include concrete, fiberglass, and polyethylene. Sizes range from 500 gallons to 10,000 gallons or more. The rule of thumb: plan for 5 to 10 gallons per person per day for household use, plus livestock and gardens. A family of 4 needs roughly 1,200 to 2,400 gallons per month just indoors. Add animals and irrigation and that number triples. In wet climates, a properly sized cistern fed by roof catchment can supply a household year-round. In dry climates, cisterns serve as buffer storage between water deliveries or as a reserve during dry spells. Cost varies enormously. A basic above-ground polyethylene tank runs 50 cents to $1 per gallon of capacity. A 2,500-gallon tank costs $1,200 to $2,500. Underground concrete cisterns run more, $3,000 to $10,000 installed, depending on size and excavation difficulty. If using cistern water for drinking, you need the same treatment as rainwater: sediment filter, carbon filter, UV or reverse osmosis. Without treatment, cistern water works for irrigation, livestock, and non-potable use. Cisterns aren't a source. They're a time machine, capturing water when it's abundant for use when it's not. Level 10. Filtration and purification, making any water safe. No matter what source you use, filtration is the final system that makes everything work safely. The treatment chain, simplest to most thorough. Sediment filtration. A basic cartridge filter removes dirt, sand, and particles, essential on every system. Cost: $20 to $50. Carbon filtration. Activated carbon removes chemicals, pesticides, and improves taste, important for rainwater and surface water. Cost: $50 to $200. UV sterilization. Ultraviolet light destroys bacteria, viruses, and parasites without chemicals. Requires minimal electricity. A small solar panel works. Cost: $150 to $500. Reverse osmosis. Forces water through a membrane, removing virtually everything: heavy metals, minerals, bacteria. Produces the cleanest water possible, but wastes some water and requires pressure. Cost: $200 to $600. Gravity filters. Systems like Berkey filters use gravity to push water through ceramic and carbon elements. No electricity, no plumbing. Pour water in, clean water comes out. Cost: $250 to $400. The go-to off-grid drinking water solution. The right filtration depends on your source. Well water might only need sediment removal. Rainwater needs sediment plus UV. Surface water needs the full chain. Test your water first, then build filtration to match. The decision framework. How to choose. So, 10 systems. Here's how to pick. If you have groundwater access and budget, drilled well is your primary source. If you have a spring on your property, develop it immediately. It's free water forever. If you're in a wet climate, rainwater harvesting with cistern storage can be your entire system. If you have a creek with elevation drop, a ram pump is the smartest low-cost move. If you're off-grid, solar pump filling an elevated tank with gravity-fed delivery to the house. The universal rule: never rely on one source. Every homestead should have a primary and a backup. Well plus rainwater, spring plus cistern, solar pump plus gravity feed. Redundancy is what separates a comfortable homestead from an emergency. And regardless of source, filter and test your water. It's the cheapest insurance you'll ever buy. That's every homestead water system explained. Figure out your water before you build anything else. Everything on your homestead, your animals, your garden, your family, depends on it.